So what I'd like to talk to you about today is, first of all, introduce my company. And secondly, I would like to talk about our technology, RCT technology. And then I'm going to talk about stage, theater, and entertainment. We've heard a few projects today about some applications in theaters. We're going to talk about that. And then we're going to get on into architectural applications on commercial lifts. And after that, we'll talk about flexible spaces, which is an interesting subject, I think, for architects. And then we'll conclude after that. So the SERAPID Group. Basically, SERAPID was founded in 1972 in France. We now have 2 factories in France, 1 in the United States, and then we have offices in Germany and in England. We also have a sales office in China, and we have a sales office here in Italy, of course. SERAPID makes eco-friendly systems that replace hydraulics with compact, simple, and reliable systems. These systems consume less energy, are more reliable, and are almost maintenance-free. We are a mid-sized business. I didn't really talk about the company enough, but we are a mid-sized company, about 120 people altogether, spread over all these different sites throughout the various offices. So what do we do? Basically, we have our own proprietary technology, and this technology has been used in many areas. First, we started out in the automotive industry. We built all sorts of things for the automotive in France and in the US and in Germany also. We make things move, basically. Whatever it is that you want to move, we make it move. And of course, lots of things move in automotive factories, and that's what we did for a long time. Then we got into nuclear. We started moving things like nuclear bundles into reactors. We moved nuclear waste and things like this. After that, of course, we got into aerospace, and in the aerospace industry, discovered our technology, and we started using it for aerospace. And next, which was towards the end of the 1990s, we got into the stage and entertainment business. And then lately, we've been getting more and more into architecture. Of course, we also have the medical market. And any of you who've done an MRI, which is, I don't know how you say that in Italian, MRI? IRM? Yeah, MRI is when you go and do a scan of your body or something in your body. If you use the Siemens machine, the system that transfers you into the whole is the SERAPID system. So what is RCT, rigid chain technology? Basically, RCT is a chain. It's a rigid chain. It's a chain that bends like any regular chain, like a bicycle chain. But when you flip it in the other direction, it becomes rigid like a bar. It's essentially a linear motion device, and it's telescopic. That's essentially what it is. It's very simple. Just like a regular chain, it has rollers, it has sprockets, it has bearings, and it has axles, and it has plates, just like a regular chain. The difference is that it can lift. If you look at the picture, this chain becomes like a piece of steel tubing when it's straight, and you can lift extremely heavy loads with it. I'm going to show you a little video of a system, like a 3D rendering of the system. Like I was saying, it's a very simple system. It's a chain with one major difference is that it only folds in one direction and does not fold in the other direction. It becomes rigid like a bar. So when you look at this product, you can see that it's big, and it is really big. It's about, the biggest system that we have is like 200 millimeters square, just like a piece of tubing. It's very large. And it can carry up to 15 tons of load. Just one unit can carry 15 tons. So what are the real advantages of this technology? First of all, it does not require a machine room. As you all know, hydraulics require a machine room. This equipment does not require a machine room. It is also, because it is rigid, it does not require balancing system between any cylinders if you use more than one cylinder. They can also be placed in any position underneath the platform for optimal carry of the load. And again, here you see the dynamic and static capacities of the product, which are very high, 15 ton. This compares the product to other technologies, jack, scissor table, cables, screw jacks, etc. So now we're going to get into stage theater and entertainment systems. This 3D modeling drawing shows you all the activity that happens on a stage in a theater, in a modern theater, of course, with everything that's been mechanized. You can see lifts, you can see wagons being translated, you can see stairways being created, you can see seat wagons being lifted, etc. And SERAPID does all of that. We do all of these movements, all of these special systems that lift or translate very, very heavy loads. So this is the technology that we're trying to apply to the architectural world, your world. We've been around for more than 40 years, so we have a lot of references throughout the world in many, many countries, in Russia, Germany, of course, UK, France, USA, everywhere. We have a lot of applications. It's moving automatically. It shouldn't move automatically, but that's okay. Yeah. Okay. One of the applications we've done is an application in Munich, Germany for BMW. And basically, this kind of gets already into the architectural world for you because it's a room that is multifunctional. This is where they do a lot of the presentations. Like I was saying, this kind of displays the kind of things that we can do in a space, in an enclosed space. The kind of flexibility that you can get from very flat floor to, like you saw in that previous video, very flat floor to a stairway set or seating that moves and all that kind of stuff. Okay. Yeah, so you get to so basically, you've seen a typical system in a theater, a very large theater, but those systems also go in auditoriums. They go in, conference halls and things like this. They don't just go in theaters. They go in many, many places. We've done a similar system at the Walt Disney Concert Hall in Los Angeles, where the lifts are set up in like a semicircle or a moon, half-moon fashion. And same thing, they can go from a flat floor to a configuration where they have a musician sitting on steps or various other things that they can do with this space, which is a flexible space. Okay. This shows the equipment being arranged in the pit that moves the lifts up and down. Another system installed in Istanbul in Turkey, which again gives you an idea of the magnitude of the projects that go into these large spaces, which we hope will happen in Italy in the near future. Lots of very, very large lifts, lots of very, very various equipment, Of course, this is only one part of it. There's also what we call overstage equipment for acoustics, for sound, for lighting, and all of that. This is a system we did in Taiwan, which, again, from a technical complexity standpoint, you can see that we have basically two lifts within each other, just like a donut. And it's a very complex system to design. Same thing with this one here. This gives you a little bit of an idea of the things we can do mechanically, how we can design things mechanically that would have to work in this type of a system. You can imagine these tables are moving in relation to each other like this. And they cannot really, you've all seen tables, I'm sure, that kind of sway back and forth like this. This cannot happen because if that happens, the cables will clash, they will crash into each other. And they cannot do that. So we had to design a scissor mechanism that is stiff enough to only allow a 5-millimeter deviation from the center line. And this is why you see this very, very complex scissor mechanism. Same thing here. Again, it's another theater, of course, in Russia, which displays our capability as a company to design complex systems. Same thing here. It's a multitude of tables. These are much larger. And they, again, they have to be very, very precise. And, of course, very reliable and very safe. This is also in Russia. The neat thing about this is that you can see in this the whole platform can tilt up and down. I talked about how stiff lifts have to be. This one had to tilt up and down. The stage would have to tilt like that. And it's a very large stage, of course, and we put basically our equipment on a pivot so that it can pivot like this with the platform. This is all mechanical, I'm sorry, but that's what we do. We are engineers. We design things. We make things happen. We make things work. This one is an interesting application also in Copenhagen, where the lifts, instead of being in the center of the platform, they are all the way outside against the wall. And the reason for that is that we needed a lot of travel, a lot of stroke, a lot of lift, and we needed to guide the chains so that they can go a lot higher. And because of that, we put them against the wall and guided them. And this additional picture shows you another style of guide, which is what we call it intermediate platforms. And this style of guide moves with the chain as the chain goes up and down. And we can see that on the next drawing. You can see the two platforms holding the chain so that because this chain, as it goes up as a column, the longer it gets, the more flex there is in the chain. So we needed to hold it in two places to stop it from flexing. This one shows the drawing of that platform that's guided along the wall, like I was saying. We did a lot of work in cruise ships and private yachts also. And a lot of this work actually happens here in Italy. Yes, so we do, again, same thing. We do a lot of lifting. And, of course, on cruise ships or on yachts, it's very special because you need to deal with the sea air and all that. So you need to have special treatments on the chain. But generally speaking, the thing that we do for customers on cruise ships is pretty much the same thing we do for other customers elsewhere. This is a helicopter platform for a yacht. We've also done a swimming pool. This was done also in Italy, I think. We've also done another type of lift on a private yacht for a swimming pool, where we lifted the swimming pool. Again, cruise ship work. In this particular case, we actually designed and built and installed rotating tables, 3 rotating tables. And the challenge with these rotating tables is that they needed to fit in a very small space, 350 millimeters, I believe. So everything, all of the equipment had to fit, had to go down and collapse 350 millimeters just above the floor. We've also worked on the Olympic Games in 2008. Same thing, the Chinese needed some very, very large tables that were working against each other like this. So they needed to be very precise and could not move any more than 5 millimeters. And they hired us to do that. And of course, we know that they've worked really well, and they still use them right now since 2008. To give you an idea of the size of these tables, you can look at the man on the right, the bottom picture that's kneeling there. These tables are 7 meters high. This project, it's definitely the biggest lift that we've ever built, and it's probably one of the biggest lifts in the world. This lift carries 300 metric tons, and it travels at 200 millimeters a second. It was originally designed with hydraulics, and our customer, once he discovered our technology, decided to change the specification and turn it into a SERAPID mechanical lift system. 300 tons. So again, this is the layout. Basically, we did the same thing in this particular case. We designed the whole system with the scissors and the lifting mechanism and all of that. The layouts, that's what SERAPID did. Just in passing, we just wanted to mention a product, one of the newest products that we have. This product is what it's called the telemast, or it's a telescopic mast. And basically, we put the rigid chain inside a set of telescopic tubes that push a charge, a load, up and down. And it can be used in many, many areas, and we sell it to people like Boeing for metrology, where they measure the outside of the plane. We sell it to Walt Disney to raise speakers and to raise lights. We sell it to the military, where they put a machine gun on top of the masts, like this one here on this picture. On top of this, there goes a machine gun, etc. We have a very extended number of applications for this product, and I think there should be applications for this in the architectural world. We've also done, of course, a few architectural applications, and I would like to tell you about them. This is some of the ones that we've done, but I'll go straight to a list of things that we can do that we have done already in the architectural world to help you understand how we can help you. Of course, we do lifts. You've seen that. We also can move rooms, move roofs, move walls, flexible venues, special purpose lifts, car lifts. We've been doing more and more car lifts these days, construction lifts, and building maintenance units, which are BMUs, which I use to service buildings, clean windows and things like this. But very high, very tall buildings, of course. This is a 3D rendering of a system that we worked on with an architect, and he designed this. It never actually happened. It was in London. It never happened, but it illustrates what we can do with an architect. He came to us and wanted to develop almost like a stage platform in a park that can be turned into many other things after it became a stage platform. It can be turned into a rest area. It can be turned into a place where people can dance and things like this. So he came to us and said, "What can you do for me?" And we came up with a number of ideas for him to do this. This application here is in Lisbon in Portugal, and it's the opening and closing of a roof. This system was installed more than 10 years ago, and we have never sold them one spare part. It's been operating since then and has never any problems. Fashion catwalk. We've done this twice, once in Las Vegas and this one in Dubai. I'm honestly surprised why this isn't used more often in shopping malls. Basically what this is that it's a fashion show with lifts that raise the models up to maybe 1 meter off the ground, and it becomes like a show with seats and all that, almost like, you know, like a theater. And then when everything is all done, you lower the lifts and it becomes a normal show floor, just like, you know, just like any other floor you can walk on it. And this system is very lucrative for the malls that use it. They rent the space to the stores in the mall. They rent them to show, to display their new, you know, new mode or new fashions. And it's very lucrative. It brings in a lot of money for the mall. And I don't understand why not more architects are designing these kinds of systems. It's basically a set of 4 lifts and a lift and a turntable. And sometimes they display cars on these things. They put a car on it, raise it up, and display expensive cars. You can see it. It's just fashion, you know. People are having fun, you know, looking at the girls and all that. This is another interesting application we've done in London. Basically, they needed to put a light on top of that tower like they should, and they needed to service that light. And of course, it's very complicated to be able to go up this high. This is, I think, the tallest tower in London, to be able to go to the top and service this thing. They wanted to maintain the integrity of this, you know, this needle. And one option, of course, is to put a stairway around this needle to go and service that system. But they had the idea of coming to us and say, how can you come up with a system to go inside this needle and be able to go up and service this light? And this is the system that we designed for them, which fits, everything fits inside that needle. This one is another lift in London for Science Museum 3D Cinema. These lifts are unique because they're very slender. What slender means is that they're very narrow like this. They're very narrow, and yet we made them become very stable, which again comes back to our ability to, you know, to design things in a very tight space and make them work. This is a National War Museum. I think it's in New Orleans. Yes, it's New Orleans. This BMU unit, which is Canary Wharf in London, this is the unit I was talking about earlier, which services the side of the building. It lowers a maintenance unit down to clean the windows and things like this. This is a bar. It's an entertainment bar, which is installed in this cruise ship. It's really very interesting because it's filled all the time because people are so excited to get on it. It raises them up to, I can't remember what they call it, but to the top of the cruise ship to be able to look around and have a view of the whole ocean. And when they're out at sea, of course, they're sitting in a bar and they're drinking, they're having fun and looking around. It's like a panoramic lift. And of course, the systems that lift the lift are in those columns that you see, those attractive columns. Everything, all the mechanism is inside those columns. And because of very, very tight spaces inside the cruise ship, the lifting mechanisms had to be done in 2 different floors. We couldn't really put them on the same floor. We had to go on the lower floor on one of them to be able to make it fit. This is another interesting one for architects because this is in a stadium, in a soccer stadium or football stadium that also is used for athletics, for like running and things like this. So during the football, they need to get the spectators closer to the field, so they had to eliminate one set of seating podiums and bring the other set closer to the field so that people are closer to the field when they watch football. When they're not watching football, they open it up and then people can run on the track. So this is again a system. This system basically is on air bearings, and it travels all around the stadium, changing the configuration of the stadium. This is the Willis Tower in Chicago. What this is it's an observation tower that allows you to stand almost on air on a piece of glass above the city, 103 floors up. It's a very, very successful attraction for Willis Tower. Many, many people go and stand there and look down 103 floors down into the floor. And of course, SERAPID has concepted and designed and supplied this system. As far as commercial lifts go, I'm going to try and go a little faster through this, but it's essentially we build goods lifts, car lifts. In fact, there's a list right here. DDA lifts, which are handicap lifts, home lifts, goods lifts, platform lifts. Any lift that you might need that is, that is not conventional. Of course, anyone can go to Otis or to Schindler and buy a lift. When it's not conventional, then people generally come to us and we can design and build this special lift for them. Like in this particular case at the Burberry store, flagship store in London, which is DDA, handicapped lift. This, I think, is a truck lift. It's at street level. When this platform that you're looking at goes down, it is at street level, which means that cars drive over it. When they want to put a vehicle down in the basement, they drive into this thing and drive it down into the basement. I'm going to run this video. It's basically showing a semi-truck being lifted up and down down into the basement of the building. This shows a lift inside a factory, a goods lift in England. Flexible spaces. What is a flexible space? A flexible space is, for example, like this space, where you could turn it from what it is right now, where you're sitting, into a flat floor, where you can have a different activity on this floor. That's what a flexible space is. And I'm sure all of you have done them and all of you know about them, but I would like to show you some of the things that we've done that are related to flexible spaces. One of these things is at the Franco Parenti Theater in Milan, Italy, yeah. So basically what this is a theater which can go from a flat floor into, it's a very basic type of a flexible venue system where all the seats are on wagons, and when you want to turn it into a flat floor, you just carry the wagons with the lift down into the basement. Very simple, inexpensive way of doing a flexible floor. This is the next one, which is more complex, but still not exactly, the optimum technologically when it comes to flexible systems. This is in Dallas, in the U.S. I'll show you quickly. So in this particular case, they're taking the seats off manually, without, not automatically, they're doing it manually. And again, you can see all those, every single little sub-unit, sub-platform goes up and down and rotates. Some of them rotate, not all of them, some of them rotate. That's another example of flexible space. Yet another example is in Darmstadt in Germany, which is a room. Again, these seats are removed manually. You can see they're just very simple seats that they can take up and down. It's a very big space, but very manual. Of course, they use lifts also to position the lift seats at the right height. This is Foundation Louis Vuitton in Paris, and this now you're getting into the sophisticated systems that are, that basically take the seats and rotate them below the floor automatically. You push a button and you change the system. This is the latest and greatest. Since I don't have much time, I want to show you this one, which is the latest and greatest design that we've just come up with. That is also a flexible space that takes care of not just straight rows, but also curved rows. So if you have curved rows, you want curved rows in the theater, this system will be able to do that for you. So basically, this is probably the most sophisticated system available out there that take the seats and rotate them automatically below the floor. And the neat thing about this is that the gap between the platforms is only 8 millimeters. And it's very constant. It does not move with time. So, a couple of last comments. We are certified as a company. We have all the necessary certifications to do lifts, both by Lift Institute, which allows us to lift people as well as goods, and by TUV, which is certification for mechanical components that also has certified us for all of the products that we have. And then to finish this, I just wanted to thank you for listening to me, despite all the issues that we've had that are, technical issues. We are here to help if you need our help. I'd be happy to provide you some advice on any kind of dream that you might have that you're not really sure how to realize it. We are the experts in moving loads vertically, horizontally. We can do drawings, we can do all sorts of analysis, we can do all sorts of things for you. Please, please contact us if you need us. That's it. Thank you for listening.